is Wayne Patterson. I'm putting together some pictures here for you guys to have a look at so you can get an idea of what we do in Australia and why we do it in Australia. Now, to give you a little bit of an idea, back in the 50s, 1950s through, say, 49 through 54, Australia went entirely from bag storage to bulk storage. And most of our bulk storage, not all of it at that stage of the game, back in the 50s, went into grain bunkers. And you're looking at one here now, as you can see it. Now, most of our commercial grain storers use grain bunkers, and I would go as far as to say that 70% of our entire 24 million tonne national crop is stored in grain bunkers in Australia. And the reason for that is very simple. It was cost per tonne of storage. In order to convert directly from bag storage to bunker storage, cost and spend on storing 24 million tonnes was very, very important. So to give you an idea now, I mean, if we were to do an average sort of comparison on silo storage versus bunker storage, you could say that we could build equivalent storage in bunkers compared to silos for between 15 and 25% of the cost of a silo. So of course, when you add that up, you can see that there's a big saving when it comes to storing 24 million tonnes. There's been a big saving if you're only going to store a couple of thousand tonnes. But the big problem with bunkers, as it was in those days with silos, was security of grain against grain loss, moisture migration, insect attack. Whilst beginning from about the 70s, we were able to buy silos with aeration involved. Certainly none of our bunkers were aerated. And we were losing, in Australia, probably 25% of our national crop to moisture migration, insect attack, shrinkage, all of those things that aeration works on. Now, what I'm doing here is that I put together this presentation for you where you can actually see some actual shots of bunkers being built. Now, you will note that some of these walls are either concrete or steel, depending on choice and availability. And generally, price-wise, concrete and steel wall works out about the same price per metre. So, but it's important to remember we can actually build bunkers without walls and do very frequently for clients. The walls can tend to go in later years. But, the main things that go together to form a bunker are really the bottom tarps and the top tarpaulins, the aeration within that then to keep the climate man-made and protected. You can see in that shot there, there's a bottom tarp that's been draped over the walls, and the next shot to come, you will see how it's locked over. So we need to create a shell of tarps on the bottom, tarps on the top, then we lock it down to the wall, and then we start the aeration. And you're looking there at some aeration duct already built within the stack. Important to remember with this duct is that it's polyurethane, so it's extremely durable. It's built to suit each fan as far as airflow is concerned, and the ability to work with the fans. So the whole thing goes together as a modular setup. There are no screws to lose. There are no seals to lose. These joints are bell and spigots, so they simply slide in together. Basically, the pipe has a lifetime guarantee, but look, it can be ripped and torn with loaders at outloading, but it's very easily fixed with fiberglass or material or plastic welding. But you can see here, it's as we come up to this next shot, you will see the excavator loaded up on the pipe itself. So it's very durable, very, very strong. Lasts for many, many years. It's designed to take the weight of the grain on its head so it doesn't overlay, but the aeration designs we use are designed to rotate air out of the stack so that we've got full penetration of air. And as we go through some of these fan photos, you will see that some of these fans are quite large. Generally, what we're looking for is 10 air changes an hour in a stack and around 20,000 litres of air delivered to the stack all over. So there's a pressure relevant to that, which is around 8 inches in water gauge pressure. Depending on the grain and the grain type, different grains require different pressures, but generally we will build to the maximum amount. You'll also see here that we have fans, and quite often do this, we build fans on trailers. So, we can move them from one site to another pretty easily. Just chuck them on the back of a ute with a tow bar and away we go. But there's one of these larger fans sitting up here for you to have a look, what we'll call MA28s, which are 20,000 litres of air a second and running on a 2-metre impeller. Now the next thing is the next shot you'll see is a diesel motor running that impeller. And in some places in the world, of course, we need generator power. We don't have mains, or conversely, we need diesels. But most cases, we use John Deere motors. We found them to be extremely reliable, and they do a very good job of driving these fans. But they are they are normally aspirated motors. They are not turbocharged. And this next shot you see is one of the first ones we built. So it's a prototype. They look a lot more encased now. They're far better produced. These next shots, you see the red fans, they're going out to Sudan at the moment to DIAC. And in fact, Dell Group and DIAC have now taken on our distributorship in Sudan for these products. And it's part of the reason why putting this video together is to try and explain why and how we do things so that people get a bit of an idea of what we're about. We also have installations in Congo, Sudan, South Africa, and across Australia, of course. Now, that shot you're looking at there is Samsam in Sudan. And you will note here, when you have a look at some of these infilling methods, that we can actually fill bunkers from the side. We can fill them from the middle of the bunker, just depending on how much grain we need to put in. But to give you an idea, I mean, bunkers can be built any length. We can build them thousands of meters long if possible. But to give you an idea, the average bunker that is 40 meters wide and 100 meters long is 10,000 tons. The average farm bunker is probably about 20 meters wide. And we generally will fill like you see here, coming down in the center. And these next shots are better. They will give you a better idea of exactly what an end filling, what we call end filling, looks like. So you can see we have concrete walls, tarp on the bottom, trucks come up, back up to the bunker. It is necessary to move those augers around in order to get a standard peak height. The last thing we want when building bunkers is a camel hump. And when you see these photos coming up of side filling, you can get a really good idea of the smoothness of the peak. So it's very important to make sure that there's no camel humps, that so the water runs off the tarps properly and it doesn't pool around the bunker. This shot gives you a pretty good idea of a side filling. And if you look closely, you'll see the aeration duct in the bottom of that. Next shot coming up is the same, but you'll also get an idea from this shot about how the tarps are laid out on the bunkers, how they're pulled out, and you can see the aeration sitting there. Next shot is just more of the same, but this shot coming up is really interesting. This is a cottonseed bunker. Notice the tarps are being sucked down, not blown up. We pull the air the other way. And that way we can preserve the tarp and lock it down. This next shot is a diesel motor running on a bunker, and you can also see there the tarp lock being pulled down. Now, this shot is interesting, and I'll just sort of sit here for a minute, but this is a silo, and you can see the moisture migration being generated within this silo. Now, that happens from sunlight hitting the walls, generating moisture within the silo due to the ambient effect of the moisture being moved in from the airflow from the walls, both up and down. It causes rot in the grain, all sorts of things. Now, we also get this in bunkers. So what we need to do, and that's why one of the reasons why our aeration plants are there. So what are the benefits of aeration? If we can drop our temperatures below 18 degrees C, we don't get insect attack in the grain, because insects are tropical animals and they don't like cold temperatures. And you might say that, hang on, in Sudan, in some places you won't get 18, but most places we can get 20 without too many problems at all. So the second benefit, of course, is preventing shrinkage in grain, being able to fatten grain using ambient moisture in the air to be able to keep the moisture content as high as we can to sale price. So if grain shrinks, it loses density, it loses weight, and of course, that's lost money in the bank. So for us, the airflow keeps the grain fresh, keeps it healthy, allows for long-term storage without losses. And to give you an idea, our loss now is 0.25%. That's about it. Okay, thanks for listening to me, and good luck.